All right. The next unit that we're going to be looking at are radicals. So we're going to be simplifying, adding, subtracting, dividing radicals. So some of this you might remember from last year. A radical expression is just some expression that contains a radical. And we've done a little bit of this. So underneath the radical is what we call the radicand. This would be the radical sign. And this number here would be the index. So there are three things you want to make sure that you have if you want to simplify radicals. One, you want to make sure that the radicand has no perfect square factors other than 1. Perfect square factors are like 9, 144, 4. Those are all perfect squares. You also want to make sure that the radicand contains no fractions. So you do not want to have any fractions underneath your radical symbol. And you don't want to have any radicals appear in the denominator. So like radical 5 is simplified because there are no radicals in the denominator and there are no perfect squares underneath the radical. But radical 32 is not simplified because 16 is a factor of 32, which means you can simplify that. Also, x over 2 is not simplified because you would have a fraction in your radical. Okay, here's one of your main properties that you're going to use. It's called the multiplication property of square roots. All it says is that if you have a product underneath your radical, you can split it up into two radicals like such. So before we do some examples, let's go through and write out all of our perfect squares so that we can use these when we simplify. So our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and let's just stop at 169. Those are perfect squares all the way up until 13. All right, so let's do our first example here. So if I have radical 60, what I'm going to do is I'm going to split this up into two radicals. Now I know from my multiplication property I'm allowed to split up. If I have radical a times b, I can split that up into radical a times radical b. So maybe let me do this. So if I have radical 160, that's the same thing as radical 16 times 10, like that. And so then what I'm going to do is split this up. I know that that's root 16 times root 10. And it was very useful to do this because radical 16, you should just know that that is 4. So 4 root 10 is your simplified radical. Let's do the same thing for 98. Root 98 is the same thing as 49 times 2. And if I split that up, that's root 49 times root 2, which is going to give me 7 root 2. So when you go to split this up in this step here and in this step here, what you're going to do is you're going to look for factors of these numbers, in this case 160 and 98. Look for factors that are perfect squares. Or another way you could think about it is you're going to look for a number that's a perfect square that will divide into that number underneath the radical. So let's do this one here. All right, we've got 5 times root 700. I'm going to rewrite this as 5 times. I'm going to make this 7 times 100. And I know that that's just 5 times root 7 times root 100. All right, so if I simplify that, that's 5 times 7 times, and then this will become 10. Now, what you want to do is this. The 10 and the 5 are being multiplied, and they're kind of like, it's kind of like saying 2 times x times 3. Like you would just multiply the 2 and the 3 and you'd say that that's 6x. So we're going to do that same thing. This is 5 times 10 times root 7. So this is going to simplify to 50 root 7. All right, so whatever number pops out of the radical, that number is going to stay on the outside and it's going to multiply whatever is already there. Multiply by whatever's already there. All right, flip your sheet to the back. Okay, now we're going to look at simplifying radicals with variables. So in this one, I have root 54 times n to the 7th. Okay, but I know that root 54 is just root 9 times 6. And I'm actually going to split up n to the 7th. Now, hopefully you remember n to the 7th is just n to the 2nd times n to the 2nd times n to the 2nd times n. Remember, if you multiply two numbers that have the same base, you add their exponents. So I'm going to rewrite that. This is going to be n squared times n squared times n squared times n. Now I'm going to use my multiplication property, and I'm going to make this. This is just root 9 times root 6 times root n squared times root n squared times root n squared times n. Let's go through this. Root 9 is 3. I can't simplify the root 6, so I'm just going to leave it root 6. But here's where we get some things coming out. Root n squared is just n. Root n squared again is n, and then again. And then, whoops, I forgot to put that radical under that one. And then I have radical n for my last one. Alright, so I'm going to multiply these four things together. That's going to be 3n cubed times root 6 times root n. But I know that I can actually combine these two things here under one radical. So that's just 3n cubed times root 6n. Okay, so this is a long way. If you want to do this step by step, that's how you'd probably go about it. But the more comfortable you get with this, the more you're going to do this in your head. So let's look at example 5. So I've got negative 21 on the outside there, and I've got 27 on the inside. So I'm going to rewrite this. Negative 21 times, this is going to be 9 times 3 times x squared times x squared times x squared times x squared times x. So if you're going to do this the long way, you would write it like this. Negative 21 times root 9 times root 3 times root x squared times root x squared times root x squared. All right. Then go through and simplify. This is going to be negative 21 times 3 times root 3 times x times x times x times x times root x. So if we simplify this, multiply these together, that's going to give me negative 63, and then multiply these together times x to the 4th. Then I'm going to have multiplied by root 3 times root x, which we can combine those with a multiplying underneath. Okay, let's try to do this last one here without using all of these long methods. Alright, the last one is 3 times square root of 150 b to the 8th. So here's what I'm going to do. I'm just going to write this out. 150 is 25 times 6. And b to the 8th is b squared times b squared times b squared times b squared. Now let's just try to do this in our heads. If I take the square root of 25, what's going to pop out of the radical? Hopefully you said 5. So I've got our 3 out there. I'm going to have to pop a 5 out. 5's going to join the 3. And then I'm going to keep going down and see what else I can pop out. The 6 has to stay. This is going to stay underneath the radical. But when I take the square root of b squared, a b pops out. Again, another b pops out. Another b. Another b. And I'm left with whatever I had just left, which was 6. Everything else popped out. So if I simplify this, this is 15b to the 4th root 6. So the more you can try to just think about this in your head, the faster they'll go. Alright, last two. I have 6 times root 75 m p squared q to the 3rd. So I'm going to rewrite. 75 is 25 times 3 times m, and I'm going to make p, I'm just going to keep p squared, but q I'm going to change that to q squared times q. So let's try to do this in our head. The square root of 25 is 5, so a 5 is going to pop out, and the 6 was already there. The 3 has to stay. The m has to stay, because you can't square root m. Nothing's going to pop out. But you can pop out a p, because the square root of p squared is just p. You can pop out a q, but then this q has to stay. So I've got a 3mq that has to stay underneath the radical. So I've got 30pq times root 3mq. All right, let's do this again. So I'm going to rewrite 48 like 16 times 3, and then I'm going to rewrite a cubed as a squared times a. I'm going to rewrite b to the fourth as b squared times b squared. I'm just going to leave c squared. Now let's go through. 16, you can take the square root of that. 4 will pop out, so I've got negative 2 already there, times 4. 3 has to stay. A squared, so that means an a is going to pop out. This a has to stay. I've got a b that's going to pop out from that. Another b is going to pop out from that b squared, and then a c is going to pop out. So what's left under the radical is 3a, and if I multiply all this outside here, I've got negative 8a b squared c times root 3a. All right, I'll be checking this tomorrow, so bring that to class.